Hi, this is Javin Kharo, a chemical engineer by profession, going to continue our today's topic, thermodynamics. Now, what is this? Thermodynamics is a science and relationship between heat, work, temperature, and energy. In broad terms, thermodynamics deals with the transfer of energy from one place to another, from one form to another. The key concept is the heat is form of energy corresponding definite amount of mechanical work. Now, what is thermodynamics? Thermodynamics in physics is a branch that deals with heat, work, and temperature in their relation to energy, radiation, and physical property of the matter. To be specific, if explain how thermal energy is converted from other form of energy, how matter is affected by this process. Thermal energy is the energy that comes from the heat. The heat is generated by the movement of tiny particle with the object, and faster the particle move, more heat is generated. Thermodynamics is not concerned about how and what rate of energy transformation are carried out. It is based on initial and final state undergoing change. It should also noted thermodynamics is a macroscopic science. This means it deals with the bulk system, does not deal with the molecule constitute of the matter. Now, what are the laws of thermodynamics? Thermodynamics is the science of the relationship between heat, work, temperature, and energy. Now, the important law of thermodynamics are the zeroth law of the thermodynamics. When two systems are each in thermal equilibrium with the third system, the first two systems are thermal equilibrium with each other. The property make it meaningful to use thermometer as the third system to define temperature scale. Now, the first law of thermodynamics, the law of conservation of energy. The change in system internal energy is equal difference between heat added to the system from the surrounding and work done by the system on its surrounding. In the other word, energy can be created or destroyed but merely converted from one form to another form. Now, the second law of thermodynamics. Heat does not flow spontaneously from colder region to a hotter region, or equivalently, heat at a given temperature cannot be converted entire into work. Consequently, the entropy of a closed system or heat energy per unit temperature increases over time towards some maximum value. These all closed systems tend toward equilibrium state, which entropy is a maximum. No energy is available to do useful work. The third law of thermodynamics. Entropy of the perfect crystal of an element, the most stable form tend to zero. Temperature approaches absolute zero. This allows absolute scale for energy to be established that from statistical point of view determine degree of randomness and disorder in the system. Also, thermodynamics developed repeatedly during 19th century in response to need optimized performance of the steam engine. The sweeping generally law of thermodynamics make applicable all physical and biological systems. In practical law of thermodynamics, it gives complete description all changes in the energy state and any system is ability to perform useful work surrounding. The classical thermodynamics, which does not involve consideration of the individual atom molecule, such concern, they are focused branch of thermodynamics, known statistical thermodynamics. In statistical mechanism, which is express macroscopic thermodynamic property, behavior, individual particle of the interaction, it has root later part of the 19th century when atomic and molecular theory matter began generally accepted. Now, we see fundamental concept. Thermodynamic state, the application thermodynamic principle began defines system that is in some of sense distinct from surrounding. Example, system could be sample of gas inside cylinder, which movable piston, an entire steam engine, a marathon runner, and planet Earth, a star, black hole, even an entire universe in general system are free to exchange heat, work, and other form of energy with their surrounding. A system condition at given time called thermodynamic state. For a gas in a cylinder, movable piston, the state of system is identified by the temperature, pressure, and volume of the gas. The property characteristic parameter have definite value, each state an independent way which system arrive at the state. Otherwise, change in value of a property depend on initial and final state of the system. The part followed by the system from one state to another. Such properties are called state function. In contrast, the work done piston move, the gas expand and heat the gas absorb from its surrounding depend on detailed way which is expansion occurs. Now, classical thermodynamics. In the classical thermodynamics, behavior matter analyzed with a macroscopic approach, units such temperature, pressure, and taken into consideration with help of individual calculate property, predict the characteristic matter undergoing the process. Now, statistical thermodynamics. In statistical thermodynamics, every molecule is under spotlight, the property molecule, and they are interact taken into consideration the characteristic behavior group of molecule. Now, chemical thermodynamics. Chemical thermodynamics is a study how work and heat related each other chemical reaction and changes of the state. Equilibrium thermodynamics. Equilibrium thermodynamics is a study of thermodynamic energy and matter approach of state of equilibrium. Now, system. A thermodynamic system is a specific portion of the matter with definite boundary which our attention focus. System boundary may real or imaginary, fixed or deformable. There are three types of systems. Isolated system. Now, isolated system can exchange energy and mass with surrounding. Universe is considered isolated system. Closed system. Across the boundary of the closed system, the transfer of energy take place. Transfer of mass doesn't take place. Refrigerator, compressor, gas piston cylinder assembly. Example, they are closed system. Open system. Open system, mass and energy both are transferred between surroundings. Everything outside of the system has direct influence behavior of the system, non-surrounding. Thermodynamic process. The system undergo thermodynamic process. There are some energetic change in the system associated with change in pressure, volume, and internal energy. There are type of thermodynamic process and unique property. They are adiabatic process, a process where no heat transfer into our system occurs. Isochloric process, the process where no change in volume occurs at the system does not work. Isobaric process, a process no change in pressure occurs. Isothermal process, a process which no change in temperature occurs. System and surrounding, steam turbine, example of an open system. Thermodynamic cycle is a process and combination process conduct much that initial and final state system are the same. Thermodynamic cycle is also known cyclic operation and cyclic process. Thermodynamic equilibrium at given state property. System have fixed value. The value of even one property change. System state changes with different value. In a system equilibrium, no changes. Value property occurs. It is isolated from its surroundings. When temperature is the same throughout the entire system, we consider system to be in thermal equilibrium. When there is no change in any point of system, we consider system at mechanical equilibrium. When chemical composition of a system does not vary with time, we consider system chemical equilibrium. Now, phase equilibrium is the two-phase system when mass of each phase reaches equilibrium level. Thermodynamic system, they are thermodynamic equilibrium, they are chemical equilibrium, mechanical equilibrium, thermal equilibrium, and Revellent parameter. This is vary with time. Thermodynamic properties. Thermodynamic property are defined characteristic future system. Capable, specifying system of state. Thermodynamic property may be extensive or intensive. Intensive property are the property do not depend quantity of matter, pressure, temperature. They are intensive property. In case of extensive property, value depends on mass of the system, volume energy and enthalpy are the extensive properties. What is enthalpy? Enthalpy is a measurement of the energy thermodynamic system. The quantity enthalpy equal total heat content of the system equivalent system internal energy plus product of volume and pressure. Now, mathematical enthalpy H equal sum of the internal energy E and the product of the pressure P and volume of V. It represented H is equal to E plus P. Okay. Now what is entropy? Entropy is a thermodynamic quantity whose value depends physical state of condition of a system. In other words, thermodynamic function used to measure randomness or disorder. In example, entropy of a solid and particle are not free to move is less than entropy of a gas where particle fill the container. Now, thermodynamic potential. Thermodynamic potential are the quantitative measure store energy in a system. Potential measure energy changes in a system. They evolve from the initial state and final state. Difference potential are used based on system constraints such as temperature and pressure. First law of thermodynamic example. Now example of the first law of thermodynamics. They are plant convert the radiant energy of sunlight, chemical energy through photosynthesis. We eat plant and convert chemical energy into kinetic energy. We swim, walk and breathe. Switching on light may seem produce energy, but it electric energy that is converted. Now, visualize the second law of thermodynamics. If room is not clean, invariably become more messy and disorderly within time. The room is clean, its entropy decreases. But effort of clean, it has resulted increased entropy outside of room, exceeding entropy loss. Third law, thermodynamic examples. Let us consider steam. Example, understand third law of thermodynamics step by step. The molecule with it move freely, it have high energy. 1 degree temperature below 100 degrees centigrade, steam get converted into water, where movement of molecule is restricted, decreasing the entropy of water. Now, when water is further cooled, 0 degrees centigrade, it converted to solid ice. In this state, movement of molecule further restricted and entropy of a system reduces more. As temperature, ice further reduce movement of the molecule restricted further and entropy substance go the decreasing. When ice is cooled absolute zero, ideally entropy should be zero, but in reality impossible to cool any substance to zero. Now thermodynamic example in a daily life. Whether we are sitting air conditioned room, traveling any vehicle, the application thermodynamic everywhere. We have listed few of these applications. There are different type of vehicle such as plant, truck, ship, work on the basis of second law of thermodynamics. three mode of heat transfer work basis of thermodynamics. Heat transfer concepts are widely used: radiator, heater, and cooler. Thermodynamics involve study of different type of power plant, such as nuclear power plant and thermal power plant. What are important law of thermodynamics? Law of thermodynamics define physical quantity, temperature, energy, and entropy. They are characteristic thermodynamic system and thermal equilibrium. What are example of the negative law? If you are pushing object along with load, work done by kinetic function is a negative. Can energy destroyed or lost? Energy can neither be created nor be destroyed. It can only transfer from one form to another form. Okay, next one. Fans converted electric energy into mechanical energy. This is explained by which law? This is explained by first law of thermodynamics. Okay. Does human body obey law of thermodynamics? Yes. When human body obey thermodynamics, you are in a crowded room with other people. You start to feel warm. You start to sweat. This is body. Way to cool itself. Heat from the body is transferred to the sweat. As the sweat absorbs more heat, it evaporates your body, becoming more disorder and transferring heat to the air, which heat room air temperature. Many sweating people, their crowded room, closed system will quickly heat and place. This is both the first and second law of thermodynamics in action. No heat is lost, it is merely transferred. Approaches equilibrium with maximum entropy. Thermodynamic summary and overview. Now, simple term, thermodynamics deals with the transfer of energy from one form to another. Law of thermodynamics, they are first law of thermodynamics. Energy can neither be created nor be destroyed. It can only transfer one form to another form. Second law of thermodynamics, entropy of isolated system always increases. Third law of thermodynamics, the entropy of a system approaches constant value. The temperature approaches absolute zero. Zeroth law of thermodynamics, two thermodynamic systems are thermal equilibrium. Third system separately when they are in thermal equilibrium with each other. Entropy of a measured number of possible arrangement atoms in a system have enthalpy is a measurement energy in a thermodynamic system. Okay guys, this is up to our today's topic, thermodynamics. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.